Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss encoder. Let's begin. Encoder is a combinational logic circuit. We can also say it is a data processing logic circuit that converts an active input signal into a coded output signal. Block diagram of an encoder. Let me prefer n number of inputs at output m number of outputs that encoder has a number of inputs, a number of input lines and many output lines, and that output line give the binary code for a given input value. This is the block diagram of an encoder. N is the number of input lines, M is the number of output lines. Here the number of input lines N is greater than that of number of output lines M, that is M is less than N. In fact, the encoder has 2 to the power m. The encoder has 2 to the power m or less number of input terminals for that of m number of output lines. We give an example to an encoder. Example: generally in a typewriter or computer keyboard, typewriter or computer keyboard, is an example of an encoder. Here the alphanumeric keyboard has 26 number of lowercase, 26 number of uppercase. It has number of lower case is equal to 26, number of upper case is equal to 26, number of numericals is equal to 10, 0 to 9, and special character, number of special character is equal to 22. So total number is equal to 84 be the input lines. At least minimum 7 bit is used, at least 7 bit is used for that of output lines. Therefore, as we say 2 to the power 6 less than 84 less than 2 to the power 7. Therefore, it has at least 7 bit is used in case of a typewriter or a computer keyboard. In this session, we discuss about two encoder. One is octal to binary and another one is decimal to BCD. First one, octal to binary encoder. An octal to binary encoder logic circuit accepts 8 inputs and produces a 3-bit output code corresponding to that of active input. It has 8 number of input lines and 3 number of output lines. In truth table, you show it inputs, 8 number of inputs. Let the inputs are D0, D1, D2, D3, D4, D5, D6, this is D7. This is 8 number of inputs, and the inputs are, if D0 here 1, in all sections this will be 0. In this way it has 8 number of inputs, 1, 2, 3, 4, 5, 6, 7, 1, all are 0. Again here we have second 1, all are 0. Next 1 is there, all are 0. One and 0. This is 1, 0. It is 1, 0, 1, 0, 1, 0. At output 3 number of outputs, and these outputs are basically named as y0, y1, y2, named as y2, y1, y0. Since it has 3 outputs, the possible situations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1. The octal to binary encoder, 8 inputs, and 3 outputs. 8 inputs, D0, D1, D2, D3, D4, D5, D6 and D7. Output Y2, Y1, Y0. Now, from that of truth table, we can express the boolean expression. The output for y0 as 1, 1, 1. In that cases, we have high. So, at y0, we have to say the possible inputs, 1 as a D1, next one for D3, next one for D5, next one for D7. Therefore, we write it from the truth table. From the truth table, first y0, output y0 is equal to, what are the high value? Here 1, 1, 1, 1. So, that one having the inputs 1 as D1, D1 plus next one having the inputs D3, D3 plus next one, here the inputs D5 plus next one inputs D7. Another output as a y1. For y1, what are the possible value of 1? 1, 2, 3, 4. That one has the inputs D2 plus 1 D3 plus 1 D6, 1 D7. Next output y2 is equal to y2, here 1 possible input is D4, D4 plus 1 D5, D5 plus 1 D6, 1 D7. In logic circuit, by using that boolean expression, we can construct the logic circuit for octal to binary encoder. Here the active lines D0, D1, D2 up to D7, and the binary code generator for D0 it is 000, for D1 it is 001, for D2 it is 010, like this. Now we realize this by taking the logic circuit. For that we have the octal inputs as octal inputs 8 number of inputs as D0, D1, D2, D3, D4, D5, D6, D7. Each one we construct the input line. At output we have y0, y1, y2. For this we use 3 OR gates. One OR gate, 2 OR gate, 3 OR gate. It has the output y0, it has the output y1, it has the output y2. For y0, to achieve y0, possible input line D1, D3, D5, D7. So D1, D3, D5, D7. Next for y1, D2, D3, D6, D7, D2, D3, D6, D7. For y2, D4, D5, D6, D7. That one is the logic circuit for octal to binary encoder. This is octal to binary encoder. It has 8 number of input lines and 3 output lines. 8 inputs lines, 3 outputs lines. We convert octal to binary by using octal to binary encoder. Another type of encoder, that is decimal to BCD. BCD, binary coded decimal system. So a decimal to BCD encoder is one kind of logic circuit that accepts 10 inputs and produces 4-bit output code corresponding to that of active input line. 10 inputs, 4-bit output code. So the 10 inputs corresponds to the 10 decimal digits from 0 to 9, and 4 outputs represent binary coded decimal value, BCD value. That kind of encoder has 10 number of inputs and 4 number of output lines. In truth table, we construct the truth table by taking 10 inputs and 4 outputs. Inputs, 10 inputs up to 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The values are written. If that one is 1, all are 0, 0 like 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 9 10. Next 1 is there, all are 0. Next 1 0. Next 1 here 1. Next 1 next 1 next 1 next 1 0. Next 1 all our terms are 0. Okay, now the outputs, 4 outputs, let the 4 outputs represented as A B C D, write it as D C B A. The possible situations, since it has 4 outputs, it will be 2 to the power 4, that is 16 number of possible conditions, but as there will be 9 such inputs, so we stop at 9th position, as it is written as 0 0 0 0 0 0 0 1 0 0 0 1. Next as 0 0 1 0 0 0 1 0 0 0 1 1 0 0 1 1 0 1 0 0 1 0 0 0 1 0 1 0 1 0 1 0 1 1 0 0 1 1 0 0 1 1 1 0 1 1 1 1 0 0 0. Next 1 0 0 1. We stop at 9th position. Decimal to BCD, binary coded decimal system. Ten inputs, 4 outputs. 10 inputs, 0 1 2 3 4 5 6 7 8 9. 4 outputs as a B C D, so D C B A. From that truth table we write the boolean expressions. From truth table output A as a high value, here high, here high, high, high. For high means 1 value, the possible inputs as 1, next 3, next 5, next 7, next 9. From that truth table, A is high, and what possible inputs? 1, 3, 5, 7, 9. Next B is high, B high, high value means 1 value, 2, 3, 6, 7, 2, 3, 6, 7. Next C, 4, 5, 6, 7, 4, 5, 6, 7. Next for D, high value 1, 8, 9. So 8, 9. For active inputs 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the BCD code are written. For 0, the BCD code 0, 0, 0, 0. For 1, 0, 0, 0, 1. For 2, 0, 0, 1, 0. Like the BCD means binary code are generated. We can construct the decimal to binary coded decimal encoder by taking that boolean expression which is generated from that of truth table. Now to construct this, first we have the input lines. Decimal inputs. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 number of OR gates, 4 OR gates, 1, 2, 3, 4 number of OR gates having the outputs A, B, C, D. When we take the output A at 1, 3, 5, 7, 9, 1, 3, 5, 7, 9. Next for B, 2, 3, 6, 7, 2, 3, 6, 7. Next for C, 4, 5, 6, 7, 4, 5, 6, 7. For D, it is 8 and 9, 8, 9. That is the logic circuit construction of decimal to BCD encoder. Decimal to BCD encoder. Here, with the help of this video lecture, you understand the idea of encoders. What is an encoder? Example of an encoder. What be the possible conditions for input lines and output lines? Two kinds of encoder, as octal-to-binary encoder. It has 8 number of inputs and 3 number of outputs. From that of truth table we construct the boolean expression and its logic circuit. Next kind of encoder, decimal to BCD encoder. It has 10 inputs and 4 outputs. 10 inputs and outputs are in that of truth table. From that of truth table we take the boolean expression, and by using that boolean expression how we implement the decimal to BCD encoder. So, with this useful and informative notes, let me wind up this session. Thank you.